All right, what's up guys? In this video, we're going to pick up some more calculus here, and this is going to be another integration practice video. This is going to be example number 3 of our integration practice series. So this will be example number 3. And so what we're asked to integrate here is the integral ln of t all over t raised to the 10th power with respect to t. So to evaluate this, we'll apply integration by parts. So let me remind you of the integration by parts formula. The integration by parts formula is the integral of u dv is equal to uv minus the integral of v du. And we just get that from the product rule, basically. And basically what you do for integration by parts, you identify what u is and then what dv is. In this particular case, we'll certainly want u to be ln of t, because remember if we pick dv to be ln of t, well, to get v, we would have to integrate dv. And so if we need to integrate ln of t, that'll require integration by parts. So we certainly don't want to pick that to be our dv. So u will be ln of t, and then that means that dv is everything else. So that means that dv will be 1 over t raised to the 10th power dt. All right, so now we find du. Well, du is the derivative of u, which is 1 over t multiplied by dt. And then to get v, we integrate dv. So that's the antiderivative of 1 over t raised to the 10th power, all integrated with respect to t. And remember, that's just going to be negative 1 over 9 t raised to the 9th power. You don't need to add a plus c for that part. We'll add a plus c at the end. Now, if you don't know how to integrate 1 over t raised to the 10th power with respect to t, use a little bit of algebra and convert 1 over t raised to the 10th as t raised to the negative 10th and integrate it, and you'll get that. Now we follow our integration by parts formula here. Remember, multiplication is commutative, so it doesn't really matter how you write the left side. You can kind of clean it up a little bit. So I'm going to go ahead and multiply things through. So I'm going to write this as negative ln of t, all divided by 9t raised to the 9th power. And then that'll be subtract the integral. And if we have v du, then that means we'll have negative 1 over 9 t raised to the 10th power. Integrate that with respect to t. So now we integrate this part. We pull out a 1 over 9, or I'm going to pull out a negative 1 over 9, excuse me. And then that just leaves us to integrate this 1 over t raised to the 10th power with respect to t again. So we already know what the antiderivative to that is, because we got it up here, remember? So this should just be negative 1 over 9 multiplied by, I'll put in parentheses, multiplied by negative 1 over 9 t raised to the 9th power. And when we simplify that, we'll get positive 1 over 81 t raised to the 9th power. And so all we have to do to finish this integral up is attach our first part here, where we, obviously followed our integration by parts formula. We just have to attach it here to our 1 over 81 t raised to the 9th power, and add a plus c because it is an indefinite integral. So our final answer for this integral, and this one was a pretty straightforward one. We're asked to integrate ln of t all over t raised to the 10th power with respect to t. So our final answer for this integral will be negative ln of t all divided by 9t to the 9th power. And this would be minus 1 over 81 t raised to the 9th power. And then you need to add an integration constant plus c to the end there. And that would be your answer. So make sure you pay very close attention to that, and that will be your answer. All right, so if you guys got any questions, let me know. I'll be more than happy to explain it. All right, guys, I will see y'all next time. Y'all take care.